We are taking R.D. Sharma solution, class 12, chapter 3, binary operations. This is VSAQ, very short answer question. The first question is, write the identity element for the binary operation star on the set R0. What does it mean, R0? It means all non-zero real numbers by the rule. The rule is A star B equals A into B by 2 for all A and B belonging to R0. So this A and B is going to come from this set only, R0. So what is the identity element? Whenever we take any element from this set and operate it with the identity element, that same element should come back. So if you take reference of A B by 2, A star E will be equal to A into E by 2. So A into E by 2 will be equal to A. So what do we get? A equals 2A. So you get E equals 2. So 2 is the identity element. Now question number 2. On the set Z of all integers, a binary operation star is defined by. So this question, second question, and the 14th question, they are similar. 14 and question number 2 are exactly similar. So in my edition, it is having 21 questions. Since 2 are exactly similar, so there will be 20 questions. So this question and 14th question are similar. Okay, let us start with the question now. See, the A star B is equal to A plus B plus 2. And this is for integers, that is set is Z for all integers. And A and B belongs to Z. So we have to find out the inverse of 4. Inverse of 4. So first we have to find out the identity element. Then only we can go for the inverse element, because A cross B will be equal to E. A cross B equal to E, what does it mean? That is, if we have A star E, it should come E. A star E, it should come A. So here I am taking A plus B plus 2, A and E I am operating, and A should come back. So E will be equal to minus 2. First we found out the identity element. Now 4 operated by something, that is the something which gives you the identity element. So this something is your inverse. So 4 operated by say B should give you E. Identity element we already found out, minus negative 2. Okay. So 4 plus B plus 2 equals negative 2, because 4 star B or A star B is A plus B plus 2. So 4 in place of A I am taking 4, in place of B I am taking B. So if you solve this, you are going to get B as minus 2 minus 6. It will be negative 8. So negative 8 is the inverse of 4 with respect to this question. Question number 3. Define a binary operation on a set. So what is a binary operation? The definition you have to give. So there are certain things you need to be very careful about. First, the set has to be a non-empty set. That is, the set should contain something like the Z, like the integer, Z0, R0, Q0, all these. And even numbered set. Then we have a binary operation. Normally we take this symbol star, and star represents plus minus division into. So this star will operate on this A, elements on A. Binary means 2 values. So 2 values A and B, these are coming from the same set, and this A and B should belong to this set. This is also very important. And when we operate A star B, the value of A star B, that is the operated value A star B, when we operate, we will get some value. That value should also go to the A, or that should also belong to A. So A star B, the final value should also belong to A. These are the 4 important aspects of calling an operation as a binary operation. Bi means 2, so 2 value will be operated at time. 4th and 5th basically commutative and associative binary operation you have to prove, or you have to define. So same thing you have to do. First you have to define the binary operation for 4th question and 5th question. The third question I answered. First you have to answer that. That is, you have to say that it is a binary operation. Okay. Once you say that it is binary operation, then we go for commutative. So if we say A and B are there in this set A, so A operated B should be equal to B operated A. Then we say that A and B can commute. They can change position and not changing the value of the result. So this is commutative. So A star B equals B star A for all A and B which is belonging to A. First thing is binary operation that you have to write. Second thing, the commutative part which I just told, this is how you have to write. Okay, A star B should be equal to B star A and A and B should belong to A. This is your commutative. Now the fifth part, define an associative binary operation on a set. Associative binary operation, same thing you have to do. First you have to define the binary operation and then associative if we have a set A and we have non-empty set and we take certain value like 3 values, and binary operation always operate on 2 values. So if we have A star B star C, if A star B, because A star B is defined, B star C is defined, A star C is defined. If we write A star B star C and A star B star C, and if we operate A star B first and then we do the result with C, and similarly A with result of B and C, these both should be equal. So this associativity is all about doing first 2 different terms and operating it with the third term. Question number 7. Write the sixth question. Write the total number of binary operation on a set consisting of 2 elements. So we have 2 elements. Just say they are A and B. Don't worry about the element. We have to count the element and then say. Now, number of binary operation on set with n elements. So we have n to the power n square. This is the expression. This is the formula you have to use. How it has come? Whenever we defined a binary operation, it has to be a binary operations which is defined on A, operation A on A, because the A is set we are taking. First value should come from A, second value should come from A, and they will be operated. And this result should also go to A, or it also belongs to A. So A taken, B taken, and the result also be from A. So how many elements are there? Let us say it has n element. Any set A, I'm just generalizing it. Right now we have 2 elements, but I'm generalizing it. So let us say it has n element. A cross B, n square element. And on the right hand side, how many element? N element. So we know that if we take 2 sets, the number of operation on a set with respect to n elements, if we say A and B, A is domain and B is codomain, A has n value, B has m value, so it will be m to the power n. That is codomain to the power domain, right? So what is codomain here? Value n, and the domain is n square. So this is how this expression has come. So a kind of explanation you can say, or a proving I have done. Now let us come back to the question. We have A and B. These are 2 elements. We can always write x, y or any m, n and m. Just there are 2 elements. And now just put it in this formula, n to the power n square. So 2 to the power 2 squared. So 2 to the power 2 to the 4. So it is going to be 16. Question number 7. Write the identity element for the binary operation star defined on the set R of all real numbers by the rule. Rule is given as A star B is equal to 3AB by 7 for all A and B belonging to this R. So we have to find out the identity element. Identity element is whenever any value from this set is operated with the identity element, the same value should come. Okay. So A star B, A star E will do. 3A in place of B will take E by 7 equals A. So this becomes A gets cancelled. E is equal to 7 by 3. So this 7 by 3 is the identity element in R with respect to this star. Question number 8. There is an expression here. Let star be a binary operation on the set of all non-zero real numbers given by A star B equals A B by 5 for all E B belong to R minus 0. So there will be no 0. Please remember, there will be no 0. Write the value of x given by 2 operation x operation 5 plus 10. So A operation is this A operation B is given by AB by 5, and we have to use this to compute this expression. So 2, then x operation 5, x star 5 equals 10. So we'll use this expression. A star B is AB by 5, so it will be x into 5 by 5, that is 5x by 5. 5 gets cancelled. It will be 2. Let us write it as 2 operation x. So 2 operation x is equal to 10. Again, we'll apply AB by 5. So it will be 2x by 5. This is equal to 10. So you get 10 into 5 by 2. 2 5 is 10. 5 5 is 25. So x equals 25. Question number 9. Write the inverse of 5 under modulo multiplication 11. See how we have already done this question in our composition table exercise, but I'll just give you a hint. I'll tell you the final result inverse also. See, first you have to write, this is multiplication, so you have to write into 11. 11 will be the subscript. And you have to write all the values, from 0. If it is not given, just assume, because it is already not given here, just write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you include 0, it will be 11 elements. Again, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No 11, okay. There will be 11 elements. So we already done. I'll just go to this solution of this 5 inverse. So whatever 5 is multiplied, we take the modulus of 11 of that value, it should give 1. Because in multiplication, normally 1 is the identity value. Plus E is 0. Identity element is 0. For multiplication, identity element is 1. So which row and column intersect at 1 for 5? That is A star B. It should equal to E, which is 1 here. So when we operate A and B, multiply, then we take the division by 11, take the remainder, and that remainder has to be 1, right? So how do we find this? See, 5 and 9. Just take 5 and 9. 5 9s are 45. So when we take 5 operation and 5 operation 9, 5 9s are 45. We have to take the division by 11. 11, 45. 11 4s are 44. And there will be 1 remainder. So 1 will be the remainder. And that is what we want. We want the identity element, which is 1. So this is, if you make the whole table, you have to just find when 5 and any of the value intersect at 1. And that value will be the inverse. Even if you operate 9 with 5, the same 1 value will come, because if 5 is the inverse of 9, 9 is the inverse of 5. Question number 10. Define identity element for a binary operation defined on a set. So what is an identity element? Identity element, if you take a set A, non-empty set, and there will be a binary operation being defined on A. Binary means 2 value will operate. So if you take a value, any value from this set, and operate it with that element, which is, we are calling it as an identity element. When we operate it with that identity element, that same value should come. A should come, not E. A should come. I'll just change it. So A is belonging to capital A, that is set. E is also belonging to capital set. So when we operate A with E, A should come. This is similar with B also. If I'm taking B, B star E should be equal to B. That is why E is being called as the identity element, because it is like a mirror. It will give you the same value back. So normally for plus, the identity element is 0. For multiplication, it is 1. Question number 11. Write the composition table for the binary operation multiplication modulo 10. So into 10 we have to do on the set S. Set is also given 2 4 6 8. So this question in the operation table, composition table, binary operation table, we have already done. So what you have to do, just write x10 here. Now set all values, you have to write 2 4 6 8 here, 2 4 6 8 on the row, 2 4 6 8 in the column. Now how these values are coming? Let us take one example or two examples. 4 and 6 I am taking. So 4, we have to take multiplication and 10. Then 6, 4 and 6 I am taking. So 6 4s are 24, multiply them. Then you take division by 10 and take the remainder, that will be the result. So 10 24, 10 2s are 20 and 4 will be the remainder. So 4 will be the remainder. This 4 is going to be put in here. So this is how 4 has come here. I'll take one more example, right? 8 and 6, for example. 8, x 10, 6. So 6 8s are 48. So 4 and 6 or 4, same result. 8 and 6, 6 and 8, same result. So you have to compute once, write it twice. Now 8 6 8s are 48. So you just divide it by 10 and the remainder has to be written. This is 10 4s are 40 and 8 will be the result. Right? So 6 and 8, 8 and 6, both ways the intersection point should have 8 value. So this is how whole table will be formed. Question number 12. For the binary operation multiplication modulo 10, so x10 we are talking about, defined on the set S equal to 1379. So let me write this set 1379. Write the inverse of 3. So we know how to make the table now. You will be able to make it. Okay. So into 10, just write 1379 here, 1379 here, and I'll tell you few or one of the values 7 and 3 how to fill it. So what do? You multiply 7 with 3, that will be 21. Then you have to divide it by 10, and when you divide it by 10, the remainder you are going to write. That is 7. This 21, 10 division by 10. So this 1 is the remainder. Okay, 10 twice, so 1 is remainder. 1 you are going to put. So 7 and 3, 1 you will put. Okay. Since it is multiplication, wherever 1 comes, what does it mean? It is also the inverse. 7 is the inverse of 3. And also the identity element. When the row and column, just see. I'll tell you one more value first. 7 and 9. So this will be 7 as a 63. You have to divide 63 by 10. And whatever is the remainder, you have to write here. 3. I'm just trying to tell you how to fill this table. So wherever we have 7 and 9, 9 and 7, you put 3. Wherever you have 3, 7, 7, 3, just put 1. And likewise, you can fill all other entries. So once these entries are done, there are first row and first column. So what you have to find out is the inverse of 3. Because inverse of 3 will only come when we know the identity element. Identity element is 1. Multiplication, normally 1 is there. So first row, second row, they both are same. First column, second column, they both are same. Why they are same? Because 1 is the identity. Okay. Now this identity, so 3 is operated with certain value so that you get 1. So 3 is operated with what value? The first example I do. So it will be 7. So 7 is the inverse. Question number 13. For the binary operation multiplication modulo 5 xy defined on the set S equal to 1, 2, 3, 4. Write the value of, let me tell you first, how are you going to make it? You have to write x5 here. This S is equal to, the set is also given to us. It's 1, 2, 3, 4. So now you know how to make it. So I'll tell you one of the value, say 2 and 3 we are taking. So 2 and x5 3 means you have to multiply 2 and 3, that will be 6. You have to divide it by 5 and the remainder you have to put. So 5 ones are 5. This 1 will be the remainder that you have to put. Right? Other values you are able to put. Okay. Now the question is saying about inverse, but there is an expression. So what is the expression? This is 3 into 5. That is 5 is the subscript. 4 inverse and then the inverse. So what is the 4 inverse? As I said, this is multiplication. So the identity element will be 1. The first row and second row are same because the operation is with 1. First row and second column are same because the operation is with 1. So 4 operate with what value so that you get 1. That is 4 inverse is found. So 4 is operated with 4, then you get 1. 4 operated with 4, you get 1. So 4 is the inverse of 4. So in the place of 4 inverse, you are going to put 4. So 3x5, 4. Right? Now 3x5, 4. When you operate this, 3 and 4, what do you get? 2. So just put 2 and then you have to find out the inverse of 2. What is the inverse of 2? You have to do that is operation with 2 so that you get 1. So what is the 1 in this row? 1. 3, for 3 it is there. The 2 operated with 3 is 1. Therefore 3 is the inverse of 2. Question number 14. On the set of integers, a binary operation star is defined by a star b equals a plus b minus 2 Write the inverse of 4. So as I said, this question was already being discussed. The second question is same as that. The second question and the 14th question are exactly similar in my edition. Maybe your edition also these questions are similar. So I'll just go ahead with the next question. So maybe the 15th is 14th here. That's the case. But you can just listen to what question I'm going to do now. So the question is like this. Write the composition table for the binary operation x5 multiplication modulo 5 on the set S equals 0, 1, 2, 3, 4. So this S is 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Now you know how to make it. I hope you'll be able to make it. Okay. So I'll tell you one of the values so that you know how to make it. So let us take 3 and 3. So 3x by 3 is nothing but 3 multiplication by 3. That is 9. Now you have to divide it by 5 and the remainder you have to take. So 5 ones are 5 and you get remainder as 4. Just put 4 here. This is the 4. Okay. Other value, I hope you'll be able to do it. Next question is, a binary operation star is defined on the set R of all real numbers by the rule A star B equals under root A square plus B square for all A and B belonging to capital R. Write the identity element for star on R. So identity element is what? When you operate A with or A or B with any value, if that value is coming back, that is the identity value. So A star E, A star B is defined as under root A square plus B square. So A star E will be defined as under root A square plus E square. So now square both the sides. A square plus E square is A square. So this E square, because A square gets cancelled, E square is equal to 0. That is E is 0. So 0 is the identity element in R with respect to this star. Okay. Next question is, let plus 6 addition modulo 6 be a binary operation on S. S is given by 0, 1, 2, 3, 4, 5. Write the value of, there is a whole expression here. So first, you know how to make the table, but because it is plus 6. So you have to add and then divide by 6 and then you have to put the remainder or the modulo. Okay. So 0 to 5 you have to write in the row and column, then you start operating. So let us take an example, 4 and 5, how it is coming. The 4 plus 6, 5, that is 4 and 5 you have to add. So 4 plus 5 is 9. Then you divide it by 6 and find out the remainder. So 6, 1 is 6, 3 is the remainder. This is 3. And the first row and second row are exactly similar. First column and second column are exactly similar. That means 0 is your identity element. Now the actual value we are going to write, that is the expression 2 plus 6, 4 inverse plus 6, 3 inverse. So you have to find it using the table. See, 4 inverse, the value which is operated with 4, it should give 1. If it should give 0, because the identity element is 0. So it is operated with 2 to get 0. So 2 is the 4 inverse. What is 3 inverse? 3 is operated with which value so that you get 0? It is 3. So 3 is there. Now 2 and 2 will operate. Just take the row of 2 and column of 2 and find out the intersection. That is what you have to do. So 2 intersection is your 4. I am saying 2 plus 2 is 4. 4 divided by 6 is what? Because the 4 is less than 6, so you will just write 4. Okay. Then you have to do the 3. So just look at the table 4 and 3, what they are intersecting. That is what you have to write. Okay. So 4 and 7 is 6. 4 and 7 is 4 and 3 is 7. 7 divided by 6 and 1 is the remainder. Next question is, this is CBSE 2008. Let star be the binary operation defined by A star B equals 3A plus 4B minus 2. So we have to find out 4 star 5. So in place of A just put 4, in place of B just put 5. So 3 into 4 is 12, 4 into 5 is 20, 12 plus 20 is 32, 32 minus 2 is 30. So 30 will be our answer. Next one is saying, let star be a binary operation defined by A star B equals 3A A star B is 3A plus 4B minus 2. No, it's A star B is A plus 3B square. I'm taking the next question here because it is CBSE 2009. Okay, so the question is A star B is A plus 3B square. We have to find out 2 star 4. So just put A as 2, B as 4. So A as 2 plus 3 into 4 square is 16. 2 plus 16 into 3 is 48. 48 plus 2 is 50. Then the next one. Let's start with the binary operation on natural number n given by A star B is HCF, highest common factor of AB. AB is belonging to n. Write the value of 22 star 4. So just find out the HCF, highest common factor of 22 and 4. So what are the factors of 22? You have to find out the HCF of 22 and 4. So common, just find out the factors of 22, find out the factor of 4, highest common factor, just write. So 22, the factor are 1, 2, 11 and 22 itself. So I'm just writing 2 and 11 because 1 and this 22 is already there. 4 is 1, 2 and 4 itself. 1, 2, 4. Okay, so what is the highest one? 2. So 2 is the answer. So the previous question was 2009. Now this is CBSE 2011. Let's start with the binary operation on set of integers I defined by A star B is equal to 2A plus B minus 3. Find the value of 3 star 4. Put A as 3, B as 4. 2 into 3 plus 4 minus 3, that is, this is 10 minus 3, that is 7. So this is the final value. Okay, this is all about this exercise. Thank you so much. Take care of yourself.